This lesson is just a short description of SWIP technological components. Each piece of equipment discussed here will have its own detailed explanation, and some will be even quite long due to its importance in SWIP technology. So, we'll start with the radio frequency scanners. And radio frequency sweep is definitely one of the most important components of sweep equipment, and we will dedicate quite a big number of lessons to get the technological concept, as this will enable the users to have the best possible results by using this type of technology. I can say that a lot of so-called professionals, unfortunately, does not have the necessary know-how to operate such equipment, and that is why I dedicate a very comprehensive insight into teaching the best way to operate such equipment and to know how to evaluate the best equipment in order to perform professional services. Now, this is important because in the market you can find thousands of brands in big range of prices, and let's say that you have a certain amount of budget and you want to evaluate the best equipment available in the market for this budget. Then I can say that you came to the right place. Because here I promise that you will learn the correct way to make the best of your investment. This part is quite technical, but I can assure you that I have invested quite a big deal of thought how to present it in the most intuitive way, so even the most technical issue will be understood in the most natural way. Okay, so since we here just making a general overview of what we will discuss more profoundly in coming lessons, I just want to comment 2 points regarding RF scanners, of course. First is the necessary capability of spectrum analyzer to detect all types of wireless signals. There's only examples: FM, AM, UHF, cellular operators, Wi-Fi, Bluetooth, etc. There are a lot of type of signal, wireless signal. I just mentioned the most popular one. So this is one issue. And the other one is that we have quite a lot of signals that have sophisticated modulations. Like, for example, pulse burst is a technique that is accumulate the information, digital information, bits and bytes in a memory, and just in one shot it send it to broadcast it like a burst. So this is why it's called pulse burst. It accumulates information in the memory and then transmit it in a burst, and this is why it is called pulse burst. Spectrum is just what it says. It's a signal that is spread to a smaller signals in the spectrum. That's why it's spread spectrum. It's very hard to detect because in most cases it is hidden inside the internal noise of the equipment. And frequency hopping is it exactly what it says. It's a signal that changes the frequency according to some, let's say, some defined scheme of where the receiver can also make the receiving this signal and understand what was the original information that is being transmitted in this way. Okay, so and of course we will talk more about all these signals. So here, just as I said, a general overview. But the detection part is only part of the mission. You need to decide if the source of the signal is external or it comes from the space that you are investigating. And even if you detected that it is an inside source signal, then you have to confirm whether it is legitimate or non-legitimate signal. So the issues are quite complicated, and we will talk a lot about it. But as I said, the RF spectrum analyzers is a very wide issue, and we'll talk quite a lot about it. So nonlinear junction detector is a must equipment in sweep services. It detects electronic circuits even if they are not energized, so it is used to detect hidden devices in walls or in any object of the space under investigation. Depending of its power, it can penetrate the object's surroundings and gives us a sign if an electronic circuit is inside the object, even if it is not energized. The object, the hidden equipment is not energized, of course. So like any device mentioned in this lesson, we will get into more details of its operational concept later on. So let's talk about portable X-ray equipment. Here we can see the use of portable X-ray device. When we get an alarm with, for example, a nonlinear junction detector, or even when we want to verify an object where it is not feasible to open or see its interior, we need to have an X-ray system to analyze and confirm the nature of the alarm or the interior of an inaccessible object, let's say. So in this slide, we can see the verification of a speaker with an X-ray system. On the left, you can see the camera that generates the X-ray waves. And on the right, you can see the panel that registers the captured X-ray after they crossed the object and were modulated to register the different densities, thus being able to create the inside image on the panel. The alternative is to open the speaker and investigate it. This might take a long time, which we sometimes do not have, and sometimes it might be even impossible to open the device without making some damage to it, which might be of an embarrassment with the client. So this equipment is quite important in sweep services. Let's see another example. Let's see here. Okay, so in this example, you can see the verification of a plant vase in the entrance to a restaurant where the VIP will arrive. It is definitely the best way to check them, to check items fast and reliably without all the hustle and bustle that can be associated with a more profound check of objects. So this is another example. You can see the camera, you can see the panel, and you can do it very fast and efficiently. Still with an X-ray, I want to show you the verification of a wall. It's a wall inspection, which is quite utile because we might get some false alarm, for example, even from nonlinear junction detection, and we want to check it, of course, without breaking the wall. And so this is very efficient, and we can see on the next slide the result that was discovered in one of the operations. Here is an electronic device exactly inside the wall, and it is being it is connected to the electric network. You can see here this wire that is basically enabled this device to work forever, because it has a constant energy source, and unless, of course, it's being detected. And then there is a wall scanner. Now, this is relatively cheap equipment that is not very precise and can give idea of existing of wire and studs that can give false alarms in some cases with nonlinear junction detection, for example. As we will see in the lesson of nonlinear junction detection, we sometimes can get a false alarm due to the existing of rust on wires or metal structures. If we have an X-ray equipment, then it is the best solution to verify what is the reason for the alarm. But sometimes we do not have X-ray equipment, and we can use the wall scanner to check the possible source of the alarm, and checking if there are wires, for example, tubes or rusty studs or stuff like this, and also maybe objects that might appear blurry on the wall scanner, but can lead us to decision of further investigations. But as I say, this is a low-cost solution and not very precise, but can be used especially where budget restriction inhibit the purchase of a mobile X-ray system, as I said before. So spy camera finder is really very low price solution to detections of camera lenses. It comprises of a viewer with some lens that actually some LEDs that emits infrared light in the visible spectrum, and it blinks in a desired velocity. So while looking through the viewer, you will be able to see camera lenses in the investigated space, as the lenses will blink at the same velocity of the infrared blinking light of the device. So you can see on the right an hidden camera lens with no activation of the cam finder. And in the middle, the lens of the camera when the cam finder is in operation. Let's see in the next slide where you can see better the vision that can be seen through the viewer of the device. So you can see on the left there is a painting that is on the wall. So take a look and you will see a blinking spot. And this is basically the lens of an hidden camera. Of course, this is an illustration just to show the what you can see through the viewer. And this is basically the idea. And I recommend to use it. The fact that it is cheap doesn't mean it's not efficient. Not everything that is cheap is not efficient. In this case, I would say that cam finder is also a procedure that must take place in a sweep service. So the sound level meter is needed for checking the level of sound leakage from a meeting room. Now, this issue will also be discussed later on with more details, but in general, we are using a pre-recorded sound that imitates the sound level of a meeting, and we place it inside the meeting room and then check what is the level of sound that can be detected outside the room. So, and I will explain it with a more, let's say, scientific way when we get to the lesson of this type of service. So another use I have to, for this device, is to check the level of sound leakage through the air conditioning tubes by checking the sound level in the opening of the air conditioning tubes in the rooms that are adjacent to the investigated room. In some cases, I saw recorders that were put inside the air conditioning tubes of closed room to the target meeting room, so the sound could be clearly recorded without needing recorded through the recorders in the air conditioning tube, and this is without needing to have access to the meeting room of the target. So it's definitely a recommended procedure that I will get into more details in a separate lesson. Thermal camera is definitely an important tool in the sweep overall toolkit. The thermal camera generates an image by detecting the level of heat of an object, and this is done by infrared light in the invisible spectrum that when it returns to the camera sensor or detector, the detector can generate a thermal image of the investigated space. The image is being constructed through the difference of heat levels that objects have in the space. So if we have an equipment in the room and it is energized, it will be seen as more brilliant, and in this way it can be detected. So if we have, for example, some spot in the wall that is like we saw, for example, in the slide of the X-ray, and when it is operated, this spot in the wall will have some brilliant spot, I would say, that would be, of course, suspicious that something is inside the wall, because otherwise we wouldn't get this signature on the wall. So, of course, as the other stuff, we'll get into more details on this issue as well. And then we have the roof inspection for suspicious electronics or suspicious antennas, for example. So we use drones to check the roof of buildings where the customer is located. Now, this is quite a tricky service since you need to identify exactly if some device or antenna on the roof is legitimate or not. If it is a private building where only one company is situated, it should be feasible to do. But in buildings where more than one company is located, it is almost impossible, since you need to know also the devices that belongs to the other companies. And this is practically impossible in most of the cases, I would say. So this was the part of the electronic devices, but electronic devices is not the only, let's say, procedures that we do in SWIP. And very important part of it is the physical inspection, which we see in the following.